Hi, welcome once again to our YouTube channel. Thanks for subscribing to our channel. Really appreciate you. It's nice you coming along with us. Today we want to quickly take some sample questions for the quantitative analysis in chemistry practical. That is what we want to look at. So we want to look at the titration aspect of the practical. So we'll be taking some sample questions that will just guide us along what the questions will be like after we must have done our titration. So that is basically what we want to do today. I want to appreciate those that have subscribed to our channel. Thanks for subscribing to our channel. We really appreciate you. And to those that are yet to subscribe, please kindly do so. So you get to benefit from all the privileges that we have on this channel. And I assure you that you are going to benefit greatly from them. Alright, so let's not waste much of our time. We dive straight into the question that we have before us today. But before we do those, I will quickly want us to quickly see some guidelines and some prerequisites to what titration and the quantitative analysis questions could be like. So we'll quickly look at some basic formulas and some other things that I feel is very necessary for us to know in the course of our practical. So this is where we're picking it up from. We're quickly going to look at what the practical manual guide is talking about, and then we'll look at some few workings on some very important things that we need to know before we quickly move into answering some questions that will be guides to us in our exams. Alright, the chemicals that we've been given, the substances that we've been given to prepare or to work with this year is potassium permanganate or potassium tetrazomanganate, as well as the iron 2 sulfate. Those are the two substances that we have been told to make use of. And we can see the mass concentration of the two substances. For our acid, we have it to be the potassium permanganate, and it is 1.5 grams per dm cube. And then the mass concentration of our base, which is the iron 2 sulfate, is 5.5 grams per dm cube. And so we will definitely be using the volume of base to be 25 centimeter cube. That is going to be the size of our pipette that we will be using for this particular titration. So before we move further, let us quickly look at what the molar mass of these two substances will be, because that will come handy when we start answering the questions that we'll be looking at. Alright, so talking about the molar mass of the potassium permanganate, which happens to be the acid, this is KMnO4. So the potassium has a mass of 39, and then the manganese has a mass of 55, as well as oxygen having a mass of 16. But we have 4 atoms of oxygen here, 4 molecules of oxygen, so we are having 16 times 4. And so when we do the maths, we have 39 plus 55 plus 64. That is going to give us a total of 158 grams per mole. So that is going to be the molar mass of potassium permanganate. Peradventure we would need it during the questions that we'll be answering in a short while. And then when we look at that of the base, which happens to be the iron 2 sulfate, this is what we have. For iron, we have it to be 56. The mass of iron is 56. The mass of sulfur is 32, and we have the mass of oxygen to be 16, like I said earlier on, and by 4. So we have 56 plus 32 plus 16 times 4. 16 times 4 is 64. So 56 plus 32 plus 64 is giving us a total of 152 grams per mole. So those are the masses for our acid. For our potassium permanganate, the molar mass is 158 grams per mole. And for the molar mass of our base, which is the iron 2 sulfate, we have the molar mass to be 152 grams per mole. Now here we have the equation for the reaction, where we have manganese oxide reacting with iron, and then we have this we have 8 electrons in that particular reaction. So this is going to be the equation for the reaction that we'll be working on. And like we can see from the reaction, our acid is we have our acid to be in ratio 1 to our base, which is ratio 5. So it is 1:5. So that is what we'll be using in our question. So we need to be very, very mindful of that. So that is that. Also, one other thing that I want us to look at is talking about some very important formula that we'll be needing in answering this type of questions. Now, suffice to say that the particular type of titration that we are having this year is a redox reaction. It's a panganometric reaction, so it is a redox reaction. So we'll be looking at some very important formulas that will be coming handy when we start answering the questions. The first formula that we have there before us is the formula for concentration. We have the CAVA over CBVB equals NaNB. CAVA over CBVB equals NaNB. So we can use this one to find the concentration of any of the substances or volume of the substances, as well as any whatever would have been asked. And then formula 2 there says mass concentration. Mass concentration equals molar concentration times molar mass. And we can tweak this mass concentration, we can tweak it to have the molar concentration or to know the molar mass. So like I said, mass concentration equals molar concentration times molar mass. So perhaps we are looking for molar concentration. Molar concentration is going to be mass concentration divided by molar mass. If we are asked to look for the molar concentration, it is going to be molar concentration equals mass concentration divided by molar mass. And if you are looking for molar mass, it is going to be mass concentration divided by molar concentration. That is how that is going to be. And perhaps we are told to look for percentage purity. This is the formula for percentage purity, where we are having the percentage purity equals mass concentration of the pure substance divided by the mass concentration of the impure substance times 100 over 1. Since it is a percentage, we'll be working with 100 over 1. And if we are looking for the percentage impurity, after we must have gotten our percentage purity, we can calculate our percentage impurity, and that is going to be 100 minus the percentage purity. So whatever answer we get for our percentage purity subtracted from 100, which is a total percent, is going to be our percentage impurity. And then looking at number 6 there. Number 6 there says number of moles of acid, that is Na in bracket like we have here. The number of mole of acid equals Ca in moles per dm cube times Va in dm cube. The Ca is concentration of the acid in moles per dm cube, that is the molar concentration, while we have the Va to be the volume of the acid in dm cube, that is the volume of the acid. And then we'll come to look at number 7. Then number 7 is talking about number of moles of base. Like we have Na, we also have Nb, number of moles of base. That is going to be concentration of base in moles per dm cube, that is the molar concentration, times the volume of the base in dm cube. And we also have the number 8 there. Number 8 says mass equals concentration in moles per dm cube times volume given in dm cube times the molar mass of the substance in grams per mole. So those are the formulas that we are looking at. Number 9 there says number of molecules of water of crystallization. Perhaps we are having question that is talking about the number of crystallization. We'll be looking at mass concentration of anhydrous substance divided by the molar mass of the anhydrous substance, which equals the mass concentration of hydrated minus mass concentration of anhydrous divided by the molar mass of the water molecule, which is 18x. And then the last formula that we need to be mindful of here is the volume of gas at STP. The volume of gas at STP, we have it to be concentration of base times the coefficient of the substance, and then times volume given in dm cube. This time around we are not going to be using the volume of the base, and then it's going to be times the molar volume of the gas, which is 22.4 dm cube. So these are the formulas that we will be using for this particular series that we are working on right now. So we'll quickly dive straight into answering the questions without wasting much of our time. So let's go along. The question 1 that we have, these are the sample questions. We have 5 sets of sample questions, so we'll work with them in our series here. So the sample question 1 that we have, question 1, it says A is a solution of 0.01 mole per dm cube potassium tetrazomanganate. 7. B is a solution of iron 2 plus containing 2.75 grams of iron granules in 500 centimeter cube of solution. A. Put A into the burette. Prepare 25 centimeter cube of B into a conical flask. Add 10 centimeter cube of H2SO4 and titrate with A. Repeat the titration to obtain concordant titer values, then tabulate your results and calculate the average volume of acid used. and the equation of the reaction is what we have here. So like I told us earlier on, we have our acid to our base to be in ratio 1 to 5. So from our results, we have to calculate all of these here. We have to calculate 1, concentration of B in moles per dm cube, 2, concentration of B in grams per dm cube, 3, mass of iron 2 plus in 500 centimeter cube of B, and then 4, we are asked to calculate the percentage of iron 2 plus in the granules. So for this particular question, we are going to be assuming our tetra value, or our average tetra value rather, to be 18.2 centimeter cube. That is what we are going to be assuming our average tetra value to be 18.20 centimeter cube. Please always make sure that your average tetra value is to 2 decimal places. So we are using 18.20 centimeter cube for this particular question. So let us quickly go straight into that. So from our question, we have our A. A is the potassium permanganate, and our B, we have it to be iron 2 plus. We have our B to be iron 2 plus. So the concentration of acid there, the Ca that we have there, is 0.01 moles per dm cube. As you can see from our question here, we have 0.01 moles per dm cube for the concentration of our acid. And then, so we are asked to calculate the mass of granules, of iron granules. That is one of the things that we are told to calculate. Okay, mass of concentration of iron granules, let us quickly see that. Mass of concentration now. Of iron granules, we have it to be 2.75 divided by 500 centimeter cube times 1000, because we are working with 1 dm cube. So they gave us that concentration in 500. Let's see it here. They gave us the concentration, you can see it here. The concentration was given in 500 centimeter cube. So we need to convert it to 1 dm cube. This value here, we need to convert it to 1 dm cube. That is why we are going in this route. So 2.75 divided by 500 times 1000. And so when we do all of this calculation we have here, so what we'll be having is going to be, we're going to be having 5.5 equals 5.5 grams per dm cube. 5.5 grams per dm cube. So this is what we'll be using for our question. And then we have our VB, which is going to be the volume of the base coming from the type of paper that has been used, to be 25 centimeter cube. So let us now see our VA from our question. We said our VA equals 18.20 centimeter cube. 18.20 centimeter cube. So the molar mass of potassium, like we have calculated earlier on from the preliminary that we did, we said the molar mass of potassium permanganate, we have it to be 158 grams per mole. I believe you understand how we got that. We can quickly turn back to the previous page where we worked on this, we explained previously, so as not to waste much of our time. So the molar mass of iron there, we have it to be molar mass. This that we have here is the molar mass of potassium permanganate, so we shouldn't get it wrong, please. And so this one here is the molar mass of iron, so we have it to be 56 grams per mole. 56 grams per mole. So this one here is the molar mass of our iron, while this one here is the molar mass of our permanganate. So let us now go to answering the questions. So we have 1, concentration of B in moles per dm cube. That is the first thing that they asked us to calculate. They said concentration of B, you can see it's a concentration of B in moles per dm cube. So concentration of B in moles, okay, let me put it this way, in mole per dm cube. Mole per dm cube. So the formula that we'll be using CAVA over CBVB equals NA over NB. So when we make it a straight line equation, we'll be having CAVA NB equals CBVB NA. And then we're looking for concentration of B, so we're having CB, making it subject of the formula. CB equals everything that is here, which is CAVA NB divided by, that is what we'll be having there, divided by the coefficient of CB, which is going to be VBNA. So that is what we are having there. So CB equals, let me just divide this page so we don't take too much of our time. So CB equals 0 from our question. We have our CA to be 0.01 times the volume of acid used, which is 18.20 times 5, which is going to be the number of moles of base. Remember we said it is ratio 1 to 5, so number of moles of base is 5, and then being divided by, it is all divided by the volume of base, which is going to be 25 centimeter cube, times the number of moles of acid, which is 1. So we have our CB here to be equal 0.91 divided by 25. When we multiply 0.01 times 18.20 times 5, it's going to give us 0.91 divided by 25, and that is going to give us our CB to be 0.0364, and this is to three significant figures. So our CB equals 0.0364 moles per dm cube. That is the answer to our question there. 0.0364 moles per dm cube. So let us look at the second question. The second question there says we should calculate the concentration of B in grams per dm cube. Concentration of B in grams per dm cube. So that is what we are doing now. 2. Concentration of B in grams per dm cube. So when we want to do that, we're going to use the formula mass concentration of B equals molar concentration of B in moles per dm cube divided by, multiplied by molar mass of B. That's the formula we're going to be using. The formula we are using is mass conc equals molar mass times the molar concentration. All of B. We're going to be using all of those to be B. So let's quickly see. The mass concentration, mass conc equals 0.0364, like we just got from here now, concentration of base. So that's the molar concentration of base, okay, yeah. So we have 0.0364 times 56. Remember we said earlier on that 56 is the number of let me show us here. 56 is the molar mass of iron that is found in that substance, in that base. So that is why we are having 56 here. So mass concentration equals 0.036. This is here we have our 0. Please, I've switched this here. Molar concentration is 0.0364 like we got here, and then our molar mass is 56 for our iron. So we have our molar mass, our mass concentration. Our mass concentration equals 2.0384, and that is to three significant figure. We'll be having it to be 2.04 grams per dm cube. So that is our answer for the concentration of B in grams per dm cube. And then we have the third one there, which is talking about mass of iron 2 plus in 500 centimeter cube of the base. Mass of iron 2 plus in 500 centimeter cube of the base. That is the next thing we want to calculate. So this place will not contain it. Let me just move to the next page. So 3. Alright, so 3 there we have the mass of iron 2 plus in 500 centimeter cube of B, 500 centimeter cube of the base. So the formula that we'll be using is similar to what we used earlier on. We'll be using mass equals molar mass of iron, molar mass of iron in grams per mole multiplied by concentration of B in moles per dm cube times we have the volume in dm cube. So those are the things that we'll be looking for. So what will our mass be? Our mass equals 56, which is the molar, we have that the molar mass of iron. So the molar mass of iron, like we have calculated earlier before, is 56 times the molar concentration of our base, which we calculated to be 0.0364 times our volume in dm cube. Remember, we are looking for the volume in dm cube, but what we're given is centimeter cube, so we'll be looking at 500 divided by 1. So let me just put it like this: 500 divided by 1000. So that is what we'll be looking at. So 500 divided by 1000 is the same as 0.5. So let me just rewrite that here: 56 times 0.0364 times 0.5. So we have our mass. Our mass equals 1.0192 grams, and that is to three significant figures. So we have it to be mass equals 1.02 grams. That will be our answer: 1.02 grams. That is the mass of our iron in the 500 centimeter cube. And then the fourth question there says the percentage of iron 2 plus in the granules. Percentage of iron 2 plus in the granules. That's what the fourth question is saying: percentage of iron 2 plus in the granules. So the formula we'll be using is percentage of iron. We have mass of iron 2 plus divided by mass of iron granules, multiplied by 100, since we are talking about percentage. So let us quickly look at our parameters. We have the percentage of iron 2 to be equal percentage of iron 2 plus. We have 1.02 divided by 2.75 multiplied by 100. So when we carry out all of this calculation, we will discover that we are having our answer to be 37 point, our answer is going to be 37.1%. 37.1%. That is going to be our final answer. So that is about that particular question. So that is how we answer all of the questions that we have for question 1. So let's move straight to question 2. So this is what we have for question 2. It says A is a solution containing 0.790 grams of potassium permanganate in 500 centimeter cube of solution. B is a solution of iron 2 sulfate of unknown concentration. Put A into the burette and titrate against 25 centimeter cube and then into the conical flask. After you must have acidified your iron 2 plus in H2SO4. You use dilute H2SO4, and then we say tabulate your burette reading and calculate using this particular concentration. So we are using 18.30 for this particular calculation here. 18.30 is going to be our average titra value. So that is what we are using for this particular concentration or particular question. So we have the equation for our reaction here. We can see it is also in ratio 1 to 5, 1 of acid to 5 of base. So we are calculating the concentration of acid in moles per dm cube, concentration of base in moles per dm cube, and the concentration of base in grams per dm cube. Those are the 3 questions that this particular question is asking us to calculate. So they also gave us some of the parameters that will be needing the masses of all of these substances. So we are going straight into answering the question right now. So question 2 now. Question 2. We have concentration of A in moles per dm cube. That's the first one we are having. Concentration of A in moles per dm cube. Concentration of A in moles per dm cube. So we are having it with concentration of A in grams per dm cube equals, okay, let's start with the mole per dm cube. Concentration of A in grams per dm cube divided by the molar mass of A. So we already know the concentration of A in grams per dm cube. So that is where we are going to pick it up from. So let's go around that. Concentration of A in grams per dm cube equals 0.790 divided by 500 multiplied by 1000. So that is going to give us 1.58 grams, 1.58 grams per dm cube. So with this now, we can now calculate our concentration of acid in moles per dm cube. So that is what we are doing now. So concentration in moles, concentration of acid in mole per dm cube now equals concentration of acid in grams per dm cube over the molar mass of acid over the molar mass of acid. So having that now, we say that the molar mass of acid that we know, we have everything to be 1.58 grams. We already know that. So concentration of A in mole per dm cube equals 1.58 grams per dm cube divided by 158 grams per mole, so we'll be having this as our answer, 0.0100 moles per dm cube. That is what we'll be having as our answer there, 0.10 moles per dm cube. So we move to the next question now. The next question is asking for concentration of B in moles per dm cube. Concentration of B in moles per dm cube. So we are using something similar to that, but this time around we'll be going through this. We are using CAVA over CBVB equals NA over NB. That is the formula we'll be using. So let's go ahead. So this question 2. Let me just write it again. CAVA over CBVB equals NA over NB. So what are the parameters that we have there? We already have our CA to be 0.01. That was what just calculated. So we have, let's make this a straight line equation first. CAVANB equals CBVB NA. And what we are looking for right now is CB. We are looking for CB. So we are having CAVANB divided by the coefficient of CB, which is actually VBNA. So what we are having there, we are having it to look like this: 0.0100 times our volume of acid, which is 18.30, times our number of base, which is 5, all divided by the volume of our base, which is 25, times the number of moles of our acid, which is 1. So our answer there is going to be, we're having 0.195 divided by 25. So that is giving us our CB now, our concentration of base, to be 0.0366 moles per dm cube. That is the answer in moles per dm cube. And then we have the question 3. Question 3 there says we should calculate the concentration of B in grams per dm cube. Concentration of B in grams per dm cube. So concentration of B now, concentration of B equals concentration of B in moles per dm cube times molar mass, the molar mass of B times the molar mass of B. Definitely we know that is going to be in grams. So we have our molar mass of B, like we have calculated earlier on. Molar mass of B equals 152 grams per mole. 152 grams per mole. That is the molar mass of B. Hence, therefore, we have our concentration of B. Therefore, concentration of B in grams per dm cube equals 0.003 0.0366 times 152. 0.0366 times 152, and we are having it to be 5.563. 5.563, that is the three significant figures. So let's change our answer to two significant figures. That will give us 5.56 grams per dm cube. So that is the answer to that particular question, 5.56 grams per dm cube. So that is about the question that we are having, the second question that we have there. So let us move to the next question, which is question 3. Question 3 there says A is a solution of potassium tetrazomanganate, B is a solution of iron 2 tetrazosulfate containing 1.4 grams of salt in 250 centimeter cube of solution. So we have to titrate 25 centimeter cube, and we use 10 centimeter cube of H2SO4, of dilute H2SO4 on that particular substance. And then we are asked to calculate all of this here. The concentration of B in moles per dm cube, concentration of A in moles per dm cube, then the number of moles of iron in the volume of B that has been pipetted. So average titral value that we are using for this particular reaction is 18.1. That is what we are using for this particular reaction, 18.1. So let's go straight to it. Question 3. Question 3. So we have our mass concentration of iron. Mass concentration of iron, we have, okay, let's quickly do that. We have our acid to be potassium permanganate, and our base, we have it to be iron 2 plus iron 2 tetrazosulfate. So our mass concentration of this, we have it to be 1.4 grams divided by 250 multiplied by 1000, and that is going to give us, okay, we are having it to be 5.6 grams per dm cube, 5.6 grams per dm cube. So the volume of B now, we have it to be 25 centimeter cube, and then our Na is 1 and Nb equals 5. So when we look at this now, our Va, we already said our Va equals 18.10. So from that, molar mass now, the molar mass of the potassium permanganate, molar mass of potassium permanganate, we have that to be 158 grams per mole. So the molar mass of iron now, like we have calculated earlier on, molar mass of iron is 152 grams per mole. Molar mass of the iron 2 sulfate, we have it to be 152 grams per mole. So now let's move to the question proper. So concentration of B in moles per dm cube. The formula we are going to be using molar concentration of B, and that is our Cb, to be mass concentration of B divided by the molar mass of B So if you are looking at that now, this is what we'll be having next. our Cb, which is our concentration of B in moles per dm cube, you having it to be 5.6 divided by 152. So our Cb is going to give us 0.03684. That is the three significant figure. We'll be having it to be what? 0.0368368 moles per dm cube. So that is going to be the concentration of our base in moles per dm cube, 0.0364. So let's move to the next question. The next question is asking us to calculate concentration of A in moles per dm cube. Concentration of A in moles per dm cube. In moles per dm cube. So we are using CAVA divided by CBVB equals NA over NB. So straight line equation is going to give us CAVA NB equals CBVB NA. I'll encourage you to always do this. If you know you probably miss a step and get it wrong, just take it step wisely and do this so you get it right. So we are looking for CA. So making CA subject of the formula now, we have all of this here, CBVB NA divided by we have the VB, the coefficient of CA here, which is going to be VANB. So having that now, we have our CA to be, our CB is concentration of base that we just calculated now, 0.0368 times our volume of base is 25 centimeter cube times our Na, number of moles of acid, is 1 divided by our volume of acid. Our volume of acid for this question, we said it is 18.10 times our number of moles of base, which is 5. So after calculating all of this now, we are having it to be 0.92 divided by 90.5, and so that is giving us 0.01016. And so we have it to be in three significant figures. It becomes our CA equals 0.0102 moles per dm cube. That is the volume of the concentration of our acid in moles per dm cube. And then we move to the third question there, which is talking about the number of moles of acid. 3. Number of moles of iron. Number of moles of iron 2 plus in the volume of base pipetted. So what we'll be using is NB equals, we have the concentration of base in moles per dm cube times the volume of base in dm cube. That is what we'll be using. So our NB equals 0.0368 that we calculated earlier on, multiplied by our volume of acid in dm cube. But remember, the volume of acid that we used is the size of the pipette, which is 25 centimeter cube. So we are going to be 25 centimeter cube divided by 1000 to get it to a dm cube. And so that is what we'll be having. So our NB equals 0.0368 multiplied by 0.25, and hence that gives us 0.0092 to three significant figures. So we have it to be NB equals 0.00920 moles. So that is going to be the number of moles of iron 2 plus in the volume of our pipette that has been that was used. So that is about the question 3 that we have. Question 4 there says, A is a solution containing 1.58 grams of potassium permanganate per dm cube of solution. B is a solution of 10 grams of iron 2 sulfate aqueous iron 2 sulfate in 1 dm cube. Put A into the burette and pipette against 25 centimeter cube, all of those, and then we have to calculate our reading. Now before we carry out our titration, we must have acidified our base in the conical flask using 10 centimeter cube of H2SO4. So we are using this as our equation for the reaction as well. So here we are having the questions that we have to work on: concentration of A in moles per dm cube, B in moles per dm cube, then concentration of the iron 2 sulfate in B in grams per dm cube. So for this particular question, we are assuming our average tetra value to be 18.40 centimeter cube. The reason why I'm working with, or why we are working with different tetra value, is because I don't want us to be based on a particular, that I want us to try them from different perspectives. So using this particular question, we are using 18.40 centimeter cube. So that is what we are using for this particular question. So let us quickly go straight into answering them. So question 4. Question 4. So we have our the parameters that we have there: mass concentration of A to be 1.58 grams per dm cube, like we have it in our question. We have it here, 1.58 grams is what we have there. So mass concentration, mass conc of A equals 1.58 grams per dm cube. And then we have our mass concentration of the hydrated salt now, of hydrated salts, that is of the B, we have it to be 10 grams. So our VB, volume of the pipette used, is 25 centimeter cube. We have our calculation this way: we have our NA and NB. NA equals 1 and NB equals 5. So when we are looking at all of this, let's quickly the molar mass of A, we have that to be 158 grams per mole, and the molar mass of B, we have it to be 152 grams per mole. So having all of this, now we go to work on A. A, talking about concentration of A, in moles per dm cube. So we know that we are having our Ca equals mass of concentration of A moles per dm cube equals what? The mass concentration of A divided by the molar mass of the same A. So that is going to give us this. We have 1.58 divided by our molar mass of A. Molar mass of A is 158 grams. Okay, let me not put this here yet. So when we do the calculation, we'll find out that we're having 0.01, and to 3 significant figure is going to be 0.0100 moles per dm cube. So that is going to be the molar concentration of our acid that has been used. And then we move to the next question, which is question 2, talking about question 2. That says concentration of B in moles per dm cube. Concentration of B in moles per dm cube. So we are using CAVA over CBVB times NA over NB. So straight line equation is giving us CAVANB equals CBVBNA. And since you are looking for CB equals CAVANB divided by VBNA. So we have our CB to be our CA, the volume of our the value of our CA is 0.0100, the molar mass of our CA like we just calculated, multiplied by the volume of acid used, which is 18.40 times 5, which is the number of moles of the base, all of which is going to be divided by the number of the volume of the base and the number of moles of acid, which is 25 times 1. So by the time we do all of the calculation here, we'll be having it to be 0.92 divided by 25, and that is going to give us, okay, let me put it here, our CB equals 0.0368 moles per dm cube. So that is going to be the value of our concentration of B in moles per dm cube. And then we have the last question there talking about the concentration of iron sulfate in B in grams per dm cube. That is question 3. Concentration of iron sulfate in B in grams per dm cube. So what we are having there, we have mass conc of B. Let me just take this to the next page. We have mass conc of B equals the mass conc of B, we know that's the molar mass of the B. It equals CB times the molar mass of iron sulfate. So we have the mass concentration of B equals the molar concentration, which is 0.0368 times the molar mass of iron, which is 152. So we have a mass conc of B equals 0.0368 times 152 will give us 5.5936, and when we move this to three significant figures, it will give us 5.60 grams per dm cube. So this is going to be the value of our question there for question 4 and 5. It says A is 0.01 mole dm cube solution of potassium permanganate, and B is containing 2.75 grams per centimeter 500 centimeter cube. So we titrate A against B using the normal values that we have been using, 25 centimeter cube of the base against our acid, after we must have acidified it with 10 centimeter cube of H2SO4. So we are asked to calculate this after we must have tabulated our results, and we are asked to calculate all of this here. So for this particular question, we are going to be using 18.10 is going to be our volume of acid. The average titral value is going to be 18.10. That is what we are going to be using for this particular question. So we are calculating the concentration of base in moles per dm cube, amount of iron in average volume of B pipetted, and then the amount of the manganese oxide in average volume of acid used, as well as the mole ratio of the manganese oxide to the iron. So those are the things that we want to work on right now. So question 5. So we already saw some of these parameters earlier on, so I will not be taking time to write them out again. But the mass concentration of our ion from this question here, mass conc of the iron sulfate, we have it to be 2.75 divided by 500 multiplied by 1000. So that is giving us 5.5 grams per dm cube. 5.5 grams per dm cube. That is what we have there. So from the question now, we have the VB. We have our VB to be 25 centimeter cube. So calculating now, we have our VA. We are using our VA to be, VA. We are using 18.10 centimeter cube. So the molar mass of, we already know the molar mass of A and the molar mass of B. So let's move straight to the first question. The concentration of B in moles per dm cube, we have the formula that we'll be using. We are using the molar conc of B equals mass conc of B divided by mass concentration of B divided by the molar mass of B. So having talked about that now, our CB equals 5.5 that we got here earlier on to be our mass concentration for B. 5.5 divided by our molar mass of B is, we have our molar mass of B to be 152. 152 is the molar mass of B, so it gives us 0.03618 with three significant figures, so it becomes 0.0362 moles per dm cube. That is our value for the concentration of B in moles per dm cube. So we go to the next question now, question 2, which is asking us to calculate the amount of iron 2+ in the average volume of B that is being pipetted. So that is where we are going to next. Amount of iron 2+, in the average volume of B pipetted. So we are having the formula that we'll be using NB equals the concentration of B in moles per dm cube, times the volume of B in dm cube. That is what we'll be using. So our NB equals 0.0362 times our volume of base, which is a volume of our pipette 25, but we are taking it to 1 dm cube, so 25 divided by 1000, so we are having it to be 0.0362 times 0.25. So having that now, we have our NB to be 0.000905 moles. That is the value that we are having there. And then question 3 is asking us for the amount of permanganate in the average volume of acid used. So we have that to be this. amount of permanganate in the average volume or average titral value of A that was used. So we are using similar similar formula. Na equals Ca in moles in mole per dm cube times the volume of A in dm cube. So we are having our Na equals, we have 0.01, that was what we were given in the question, 0.01 times 18.10 divided by 1000. So this is giving us 0.01 times 0.0180 or 0.0181 rather, and that is going to give us 0.000181 moles. So that is the value of the amount of permanganate that is found in the volume of our acid. And then we move to the next question. The next question, which happens to be the last question, is talking about the mole ratio of permanganate to iron. Question 4. Mole ratio of permanganate to iron 2 plus. So Na now, Na equals 0.000181 moles, and we have our Nb to be 0.000905 mole. If you look at this now, we are dividing by the smaller number. So divide both sides by the smaller value. Divide both sides by the smaller value. So Na is the smaller value. So Na equals, we have 0.000181 divided by 0.000181, and that is going to give us 1. And here we have our Nb. We have our Nb to be 0.000905 divided by, we have it divided by 0.000181, and that is going to give us 5 when we do the calculation. So that tells us that our mole ratio for the equation is going to be 1:5. 1:5. So that is going to be the answer to the question. So this is as far as we can come for the questions. We have been able to answer 5 questions in this particular series. I'll plead with you to try as much as possible to go through all of the questions again and familiarize yourselves with the answers that were given to each of these questions. Try to understand the steps that were given to all of the questions and get more questions to practice. And hopefully with this, you'll be able to do it right and get it right in your exam. I wish you success in your exam. And for those of us that are yet to subscribe, please kindly subscribe to our channel and like this content. Share them with your friends. I want to hear from you. So please, perhaps you have any question, don't forget or hesitate to put them in our comment section, and we'll do well to get back to you. Thank you very much, and God bless.